All right, so we're going to coerce all of this tree data into a Pandas data frame. And before we do that, new cell, let's change it to a markdown cell. And I'm going to paste in an index to the pitch fields. So let's run that as a markdown. Turns into a link for me. Again, really nice to have it right in the notebook itself. And let's click it. And what you'll get is you'll get the Mike Fast blog, and he talks about each of the fields. So DES is a brief description of the result of the pitch, strike, foul, foul tip. So DES is our final disposition of that pitch, the IDs, the types, the start speeds. Now you'll notice a couple things in here. SC top, the strike zone top, and the strike zone bottom. This changes. Sometimes it changes during the at-bat. And what I've decided is whatever the strike zone top and bottom started as. So my understanding is this is a technician who's either pointing a laser or somehow gauging, where the belt buckle is. So it can change. It certainly changes batter to batter. It can even change within the at-bat. But anyway, here's a nice glossary of what all these fields mean over in the XML. So that's there for your convenience. And with that, again, what we're going to do is we're going to coerce all of this frame data, all this tree data, into a database or what's called a Pandas data frame. Essentially what we're doing is we're going from these tree structures to a data frame, and the best way to think of that data frame is as an Excel spreadsheet. And I've got a mock-up here, and basically what we're doing is let's take an at-bat, let's say at-bat number 22, and some of the data will be redundant. So at bat 22, if it had 3 pitches, would start to look something like this. And let's say this was Dickerson. Then what you're going to do is each of the pitches will turn into a row. And some of the information, unlike the tree structure, will be redundant. So Dickerson, the batter name, will be duplicated in each row, and the pitches will be unique, but the AB is the same. So what that's going to give us is the ability to say, how did Kershaw pitch to Dickerson across the entire game? So we can go get all of the batter names Dickerson, and we can get that portion, of the spreadsheet out, and we can look at those and we can graph those pitches. And what it also does, it's just a more efficient way to wrangle the data without walking through the tree each time. So that's what we're going to do. We're going to build a data frame, and with that, let's start in this new cell. And the basic idea is we're going to use the same loop through the data frames that we did before. So let's paste all of that down into there. And now, the other thing I'll say is we don't need the pitch dictionary because it's redundant. We've established it up here, and like I said, when this cell runs, that pitch dictionary variable, which in this case is a Python dictionary object, will be set. So we'll have it. Now what we will need, though, let's go ahead and paste in a definition of the data frame that we want to build. So in this case, rather than type it, let me just say that our pitch DF, which is our pitch data frame, we'll put it right under here, equals PD, and if you remember, let's go all the way to the top, PD was Pandas. So we imported Pandas as PD, so we're now saying PandasDataframe, where the columns equal the following. So what we've got to do is we've got to create the rows, and we'll create those rows, and we'll remember, for example, the batter name until the batter changes, and what we'll do is we'll insert new rows. But to do that, we're missing some fields. So if you look at the fields that we said this data frame would require, we don't have all of those. So let's put those in, and we'll start with, we've got batter name, and we've got pitch count. Let's do this. Let's, instead of just total pitches, let's put in top pitch count. A couple things I want to track, and that would equal 0. And we'll do bottom pitch count. So of course the top will be all of the pitches that Kershaw threw. The bottom will be the various pitchers that Colorado went through, but we'll start them all off at 0. And now what we want to do, we've got batter name. We don't have the stand. Notice up here we've got a stand column. We want to know as we plot which side of the plate the batter was on. So let's say that stand side equals, and it's the at bat, and we'll get the property called stand. Okay, so again, we want to make sure that we've got all of the variables that we're going to need to make one row with each pass through the pitch data. So that gives us stand side. Let's say that AB index equals the at bat dot get num. If you remember, over in our raw data, each at bat had a num. Okay, so we got at bat number 13, number 14. So there's our ordinal as we go through the at bats. So here's where we get our pitches, and it turns out if you intentionally walk someone, the pitch itself, the speed, the location are basically null. They're, in Python terms, they're none, and that's because under the current rules you just tell the runner to take their base. So let's say if pitch dot attribute dot get the start speed, if that is none, it was a non-pitch, let's set speed equal to 0. So again, that's just the variable speed. We've got a local variable, and else we want to make speed equal to, and we'll cast this into a float, and that would be pitch dot attribute get start speed. Okay, so that's how we set speed. And again, we're just trying to round up all the variables we're going to need to create a new row. Now, we haven't yet got any location data, so let's say px float. We'll name our variable px float. Unlike the row above it, or the line of code above it, we're going to set this to 0, 0. And then we're going to use the ternary construct in Python. And we're going to say that's only true if pitch dot attribute dot get px equals none. So if it's none, set it to 0, 0, else we're going to cast it into the float. And here what I've found out is that the numbers that they actually record have many, many decimal places, more than we need. So I'm going to use the old like printf function. If you're a C, C++, or Java programmer, you've got a printf or sprintf. We're going to format this into a 2-digit decimal using 0.2f, and then that becomes a format of the float of, once again, getting the pitch attribute called px. Okay, let's get our braces right here. Run, and there we go. So it looks like we're now getting the px float information. And with that, let's just copy this line. And let's paste it for our z data. We'll paste it for our strike zone top and strike zone bottom. So px pz float. And let's go with sz top. And SC bottom, and that equals, in this case it would be, we're getting the attribute PZ. And again, setting all these to 0, 0 if they're none. And in this case, it's the attribute name is SC top. Copy that over to here. Now, what you'll notice is what I'm doing is very simply saving myself from needing 4 lines of code here, where you say if it's none, else do this, and I'm using the ternary operator to get it all into one line. So double check that is the names of our properties over here. So within a pitch, and again, like I said, it can change. Here's SC top and SC bottom. So that's the names of our variables. Now at this point, let's do this. Let's say print, and let's just say px float. PZ float. SC top. SC bottom. And make sure it still runs. Okay. So there's the 4 new variables, and this is pitch location data. So again, we're working towards getting all the row data that we need in order to put that row into the Pandas data frame.